All right, guys, welcome to 11.2. Today we're going to learn how to solve some basic trig equations. So first of all, what does it mean to solve a trig equation? Well, first of all, they look like this. You're going to have either sine, cosine, tangent, secant, or one of the 6 trig functions we talked about. Then you're going to have a theta here, and then you're going to have a number over here. And our goal is to find the measure of the angle. So sine of what angle equals a half? That's our goal there. So that's what it means to solve. We're going to break this lesson up into 2 parts today. The first part is solving trig equations that involve sine, cosine, and tangent. The second half will be the other 3, which is secant, cosecant, and cotangent. So here are the steps we're going to follow to solve some basic trig equations that have sine, cosine, and tangent in them. First of all, if it's sine, well, as you guys may recall, sine is equal to the y value. So basically, I'm going to look at this number here, and I'm going to recognize, oh, that's a y value. And I'm going to look at my unit circle, and I'm going to find where are the y values equal to, in this case, a half. And then my goal is to find out what angles are at that point. And it could be in radians and or degrees. So basically, if it's sine, find the y values that equal that given output, and then we can state the angles that go with it. If it's cosine, so if I were to change this, for instance, to cosine, then instead of looking for where y equals a half, we would be looking for where the x value equals a half. If it's a tangent function, so instead of sine, let's say it was tangent, in that case, we're going to use the tangent unit circle that we created last class. So there's that, and without any further ado, we'll go ahead and jump in here. So example 1 says find theta, in other words, find the angle, and we're going to state the radians and degrees. Find theta, provided that theta is between 0 and 360, or if we're doing radians, between 0 and 2 pi. Okay, I'll explain why I state that in just a moment. All right, but let's go ahead and begin. So let's find this one. Sine of theta equals a half. I'm going to fast forward here to my unit circle that I've put up for today. So since I'm looking for where sine of theta equals a half, that means I want to find where does y equal a half, because sine is the y value, and so I want to find where is the y value equal to a half, and the y value is the second number in the ordered pair. So here's one place where y equals a half, and then directly across from it over here there's another one. So as you guys can see, there's going to be 2 places where y equals a half, and so we have basically 2 answers. We have these angles in radians and degrees, and we have this angle in radians and degrees. And so the answer to number 1 will be theta equals either pi over 6 or 5 pi over 6 if you want to give it in radians, or we could say in degrees that it equals 30 degrees or 150 degrees. So there are 2 answers. So if sine of theta equals a half, in other words, y value equals a half, there's 2 angles that will create that situation, either 30 or 150, or if you want to say it in radians, pi over 6 and 5 pi over 6. All right, let's go ahead and take a look at number 2. Number 2, cosine of theta equals negative radical 3. Cosine of theta equals negative radical 3 over 2, sorry. So cosine of theta equals negative radical 3 over 2. Let's find where that's located. Now cosine is the x value. So this is saying, where does x equal negative radical 3 over 2? All right. Well, let's find some here. Here's one. Now this is negative, we want negative radical 3 over 2, right? So this is a positive. We want negative radical 3 over 2. So this is not an answer. This is positive, but this one is. So here's a negative radical 3 over 2. And there's going to be another one directly across from it down here. Now you guys are noticing this is the second time we've had two answers, and the reason for that is that's going to happen every time because the unit circle is symmetrical, and so you kind of have some repeated answers there, right? And so what is my answer? Well, here's one angle where cosine equals negative radical 3 over 2, and here's another angle where cosine of theta equals negative radical 3 over 2. And so we could state the answer in degrees, which would be 150 degrees and 210 degrees. Or we could state it in radians, and that would be 5 pi over 6 or 7 pi over 6. Okay? Let's go ahead and move on to the next one. Where is it? There it is. Okay. Let's do tangent of theta equals 1. Tangent of theta equals 1. For that one, we're going to look at our tangent unit circle. So where does tangent of theta equal 1? Well, tangent of theta equals 1 here, and it also equals 1 over here. And therefore, there are two angles. So here's one pair, and here's the other one. So that means that theta would be either 45 degrees or 225 degrees if you're doing degrees. And if you're doing radians, that would be pi over 4 and 5 pi over 4. And so we've done one sine, we've done one cosine, we've done one tangent. We've got a few other things I want to look at, but something I want to remind you guys of is, why do I keep saying, why do the directions say find theta provided that theta is between 0 and 360 or between 0 and 2 pi? Why do I state that? Well, because we learned a little while something about coterminal angles. So for instance, right here at 30 degrees, cosine is radical 3 over 2, and sine equals a half. But as you guys know, if I go all the way around, just come back to that, I'm at the same spot, so I get the same x values. So technically, if I were to ask you guys, if I were to say sine of 30 equals radical 3 over 2, well, so does sine of 30 plus 360, which is 390. That's a coterminal angle. If I add 360 to this, I get the same angle again. So it's like going all the way back around. And so that's also equal to, I put the answer. This is supposed to be a half. The y value is a half, my bad. So sine of 30 is a half, and so is sine of 390. And that could keep going, because I could keep adding 360 to this. If I add 360 again, I'll get the same answer. And if I add 360 again, I'll get the same answer. And so technically, whenever you see sine of theta equals a half, there's an infinite number of angles that can go here that would give us a half. And so because of that fact, I have to explicitly state, well, we can't go on forever, right? So I just say, make sure your answers just stay between 0 and 360, or if you're doing radians, between 0 and 2 pi, okay? So there's that little note. Now let's go ahead and take a look at number 4. Cosine of theta equals 1. So cosine of theta equals 1. So now this question is asking us, where does the x value, because it's cosine, right? Where is x equal to 1? We'll take a look at your unit circle and find it. It's right there. And actually, there's only one place where that happens. So as you guys can see, there's only one answer this time. Usually there's been two every time. And that's going to happen anytime you have an answer that's here, or here, or here, or here. You're only going to get one answer anytime your angle is on the axis. So I only have one answer here. The answer is 0. And we just have to put 0 this time. I don't have to put 0 degrees and 0 radians. 0 works for both. So I'll just put theta equals 0. Okay, let's go ahead and take a look at one more question here. Now, before I do that, though, let's look at all these numbers here for x and y. Think of this as a decimal. This would equal 0.5. And this number here is if you were to change it into a decimal, that's about 0.866. Both of these numbers here are the same, and they both equal about 0.707. Okay? And these numbers are the same as these ones. They're just switched around. You guys notice something about all three of these numbers. All three of these numbers are less than 1. So as you guys can see, no matter where you're at on the unit circle, the x value and the y value are always either 1 or less than 1. They can never be greater than 1. And the reason for that goes back to something we talked about a little while ago. Remember how we drew triangles here? And this was the hypotenuse was the radius of our circle, and that's 1. Well, in a right triangle, the hypotenuse is the biggest side. And so it's impossible for this side or this side to be bigger than 1. And those are the sides that give us our x and y value. So my point here is that x and y are always equal to or less than 1 on the unit circle. And that means that sine and cosine always have to be equal to or less than 1, or negative 1. They can't be anything beyond that range. And so sometimes, just to trick you, they'll give you questions like this: sine of theta equals 2. But that's impossible. There's no solution to this. And the reason for that is because sine and cosine always have to be between -1 and 1. They can never be greater than or less, greater than 1 or less than -1. They've always got to be somewhere in between there. So there's no solution to these types of questions where it's equal to something greater than 1. All right? So let's summarize some of these notes that we've made as we went along. So our first note is that there's technically an infinite number of answers. But for today, we're going to be sticking to answers that are between 0 and 360. Okay? Second note, typically there's 2 answers. So notice for a lot of the problems we did, we kept getting 2 different angles that would give us the desired outcome. But there is an exception. Anytime you have an angle on the axis, you only get 1 answer. And then finally, another thing that we noticed was that sine and cosine can only be between -1 and 1. So keep those things in mind. So let's go ahead and give you guys some student practice here. Go ahead and pause the video here, and when you unpause it, you will see the solutions. All right, so here's your solutions. Go ahead and pause the video here, check your work, and reevaluate your answers if you didn't get one of these right. Take note on number 3. There's only one angle. In degrees, it's 270, or in radians, it's 3 pi over 2, and that's because this would be an axial angle. On number 4, there's no solution because this is a really weird looking number, but if you change it into a decimal, you'll find that it's slightly bigger than 1, and as we stated, cosine is not allowed to be bigger than 1. Okay, so there's our answers to that. Let's go ahead and move on to our next part. So we talked about how to solve trigonometric equations that have sine, cosine, and tangent, but what if they have secant, cosecant, and cotangent? What we're basically going to do is we're going to change them into sine, cosine, and tangent. So if it's secant, we're going to change that into cosine by just taking the reciprocal of the number that they give us. If it's cosecant, we're going to change it into sine by taking the reciprocal. If it's cotangent, we're going to change it into tangent by taking the reciprocal. After that, we can just solve it using the process that we've already discussed, because at that point, it will be either sine, cosine, or tangent. So let's go ahead and take a look at example 2. Once again, find the theta in radians and in degrees, provided that the angle is between 0 and 360 and 0 and 2 pi. All right, so let's begin here. So number 1 is secant theta equals 2. All right, so secant. I want to take the reciprocal of this expression. If I take the reciprocal of secant, then that gives me cosine. Since I took the reciprocal on the left side, I need to take the reciprocal on the right side also, so 2 becomes 1 over 2. So now, these two things will give me the same sets of answers. I just took the reciprocal on both sides, okay? And so now I've got something I can work with. So now I'm looking for where does x equal a half? Well, let's go ahead and find it. I see one right here, and I see one right here. And so the answer to number 1 in degrees will be 60 degrees and 300 degrees. Or in radians, it would be pi over 3 and 5 pi over 3. Okay, there's our answer to number 1. Let's go ahead and take a look at our second problem. Cosecant of theta is equal to radical 2. Is that the right one, or was that the student practice? No, okay. Cosecant of theta equals radical 2. All right, so let's take the reciprocal on both sides. The reciprocal of cosecant is sine, and the reciprocal of radical 2 would be 1 over radical 2. And as you guys know, we don't like having square roots on the bottom, so I'm going to multiply the top and the bottom by the square root of 2, and that will give me this outcome. So now I'm looking for where does the y value equal radical 2 over 2? And that would be here and here on the unit circle, and therefore we have these two angles as our solutions. So in degrees, it would be 45 degrees and 135 degrees. And in radians, it would be pi over 4 and 3 pi over 4. Okay? Let's go ahead and take a look at number 3. Cotangent of theta is equal to radical 3 over 3. So the first thing I'm going to do is I'm going to take the reciprocal on both sides. The reciprocal of cotangent is tangent. And the reciprocal of radical 3 over 3 is 3 over radical 3. And once again, we don't like square roots on the bottom, so I'm going to multiply the top and the bottom by the square root of 3. And now I've got tangent of theta is equal to 3 radical 3 over 3. And these cancel out. And so all that simplifies into tangent of theta equals radical 3. And so now that I've got that, we're going to go ahead and take a look at our tangent unit circle. And we're going to find where does tangent of theta equal radical 3. Well, there's one right here, and there's one right here. So those angles are here and here. And so our final answer then will be 60 degrees and 240 degrees if we're doing degrees. And if we're doing radians, it would be pi over 3 and 4 pi over 3. Okay, let's go ahead and take a look at one more example problem. Secant. So take the reciprocal of both sides. The reciprocal of secant is cosine. And the reciprocal of negative 1 over 2 is negative 2 over 1, which is just negative 2. But this has no solution because, as you guys know, cosine can't be less than negative 1. It's got to be between negative 1 and positive 1, so that's a no solution. Okay? Let's go ahead and have you guys try one of these. Here is a student practice. So go ahead and pause the video, and when you unpause it, you will see the solutions. All right, guys, so go ahead and pause the video here and study these answers. Check yourself, see if you're right. And a little note here about 4. I just realized something I didn't do earlier whenever I got a 0 answer is I actually could have written the answer out a little bit more instead of just saying 0. You could say 0 or 360 because those are coterminal, and that's technically still on this interval, right? And therefore, we can write it as radians as well, 0 and 2 pi. So anyway, I'll go ahead and let you guys study that. You can pause the video there when you're all done. That's it for the lesson. So hopefully that was helpful, and we'll see you guys in class to practice this stuff.